Hello friends, welcome back. Hearty welcome to you. We have to find out the integral of 1 by sine to the power of 4x plus cos to the power of 4x dx. To start with, we will divide both numerator and denominator with cos to the power of 4x. Then we will take tan x equal to t. Let us see how the steps will be. The first step will be 1 by cos to the power of 4x, that is secant to the power of 4x dx, divided by sine by cos we know is tan, so it becomes tan to the power of 4x plus 1. Then we will take tan x equal to t. We will have secant square x equal to dt by dx. We also know that if tan x equal to t, then secant square x equal to 1 plus t square. Now let's go and try to convert the given integral in terms of t. We will have secant square x dx, which can be written as dt, and the denominator becomes 1 plus t power 4. So we can write that in the next step. We will have integral of secant square x, that is 1 plus t square into dt, divided by 1 plus t to the power of 4. Now, you know that whenever we are in a scenario where we have t square plus 1 by 1 plus t power 4, always we try to modify in such a way that the numerator becomes derivative of the denominator. So for that, generally we take t minus 1 by t or t plus 1 by t into another variable. Now let's first try to divide this with t square. We will have 1 plus 1 by t square dt divided by t square plus 1 by t square. Now what I have to differentiate so that I can get 1 plus 1 by t square as derivative? We know that is t minus 1 by t. So let us write down t minus 1 by t equal to u. Then we know that 1 plus 1 by t square equal to du by dt. Now how we can write down t square plus 1 by t square in terms of t minus 1 by t? We can write the denominator, that is t square plus 1 by t square, as t minus 1 by t minus 1 by t whole square plus 2. Converting into u, we will have du divided by u square plus root 2 whole square, which is a standard integral, so we can write it as integral of, it is of the form of dx by a square plus x square. So the integral is 1 by a, 1 by root 2 tan inverse of x by a, that is u by root 2 plus c, back substituting u equal to t minus 1 by t and t equal to tan x. We will have 1 by root 2 tan inverse of tan square x minus 1 by root 2 into tan x plus c, because we know u equal to t square minus 1 by t and we know t equal to tan x. So it will become 1 by root 2 tan inverse tan square x minus 1 by root 2 tan x plus c. Now the same problem can be solved in another way. In that method, we'll try to convert the denominator in terms of a plus or minus b sin x or sin t, a plus or minus b cos t. Then we will take tan of x by 2 equal to another variable, or tan of t by 2 equal to another variable. Now the power we see here is 4. Now 4, 2 we have to go to 2, 2 we have to come to 1. That means we have to get rid of those powers. So let's do a little bit of work here. What is sine to the power of 4x plus cos to the power of 4x, which is in the form of a square plus b square? So I can write it as a plus b whole square, that is sine square x plus cos square x whole square, minus 2 sine square x cos square x. Now which is equal to 1 minus 2 sine square x cos square x. We know that is equal to 1 minus sine square 2x divided by 2, because we know sine 2x equal to 2, sine square 2x will be 4 sine square x cos square x. Now from power 4 we came to power 2. Now how to convert this again from power 2 to power 1? For that what we will do, we'll write down sine square 2x as 1 minus cos 4x by 2, which is equal to 1 minus cos 4x divided by 4. You should be okay with these formulas. We learned this as part of 11th class multiple and submultiple angles. Now simplify this. We will have 4 minus 1 3, then afterwards we will have plus cos 4x divided by 4. Now this value we are going to substitute in the given problem. What we need is integral of dx divided by sine to the power of 4x plus cos to the power of 4x, but that can be now written as 4 dx divided by 3 plus cos 4x. Now let us take 4x equal to another variable t. Then we will have 4 dx equal to dt, or 4 equal to dt by dx. Now let's try to convert this in terms of t. Now we will have dt divided by 3 plus cos t. Let us take tan t by 2 equal to another variable u. Then we will have half secant square t by 2 is dt equal to du. Also we know that secant square t by 2 is equal to 1 plus u square. Now let's go ahead and try to convert this in terms of u. We will have dt equal to 2 du by secant square t by 2, that is 1 plus u square, and 3 plus cos t. What is cos t? Cos t is 1 minus tan square t by 2, that is 1 minus u square, divided by 1 plus u square. So we know that cos 2t equal to 1 minus t square by 1 plus t square. So cos t equal to 1 minus tan square t by 2 by 1 plus tan square t by 2, that is 1 minus u square by 1 plus u square. So let us simplify that. In the next step we will have 2 du divided by, take LCM, we will have 3 plus 1 4 plus 2u square, and 1 plus u square will come to numerator, and we have one more 1 plus u square here. They both will cancel. We can cancel them. So left out is 2 du by 2a square plus 4. I can take 2 out. I have u square plus root 2 whole square. Now this is again standard form, and we know the integral of that is 1 by a 1 by root 2 tan inverse of u by root 2 plus c. But what is u? u is tan t by 2. So can we write down 1 by root 2 tan inverse of tan t by 2 by root 2 plus c, but we know that t equal to 4x, so we can write down 1 by root 2 tan inverse of tan 2x by root 2 plus c. So that will be our final step.